Okay, here's a pretty standard IGCSE type graphing exam question. So we're going to solve it with a CG50, Casio FX CG50. So you are presented with a pair of axes, and they're very handily, they have 4 key numbers on them. So you've got the x-axis that has a 15, it goes up to 15 and minus 15, down to minus 15. And the y-axis goes down to minus 15 and up to 20. Then you are told f of x equals 10 cos 20x for x between minus 15 and 15 inclusive. So x is greater than or equal to minus 15 and it's less than or equal to 15. So part A, we are asked, on the diagram, sketch the graph of y equals f of x. So sketch the graph of 10 cos 20x. So these questions, they are all about the viewing window. So there is another issue in this, is the fact that you need to make sure you're working in degree mode and not radian mode. But I'll talk about the viewing window first. So you're told that x is between minus 15 and 15. You're very handily told that y is between minus 15 and 20. So what you need to do, you need to make sure you are looking at exactly that bit of the function once you get it graphed. So imagine we sort of had a box drawn around these 4 key values, something like that. And you kind of need to imagine that that box is your calculator screen. So you're going to tell your calculator that that is exactly the bit of the function you want to look at, no more, no less. Okay, so we're now going to go over to the calculator, and the first thing I'm going to do before I do anything, and in fact you should always do this in an exam, an examiner should go around at the beginning of the exam and make sure they've reset all calculators. Now if they've reset all the calculators, your calculator will be defaulted, it defaults back to radian mode. So any IGCSE question, you're not going to be working in radians. And if you're working with trigonometry, then if you're working in the wrong unit, it is going to make your answers wildly different. So I'm going to press Shift Menu, and I'm going to have a look at here. So actually, I've said all that, and I am in degree mode anyway. But let's just imagine I did that again. And I come down here, and I think, oh no, look, radian mode. You need to make sure you're working in degrees. So I go there. I need to change it to degrees, just like that. Exit. And you're ready to go. So now we can go to the actual graphing bit. So menu, the graph feature is number 5, so you could just press 5. I'm just going to go down there. Okay, so I've got old functions in there from previous examples, so I need to get rid of anything that you don't want. So delete formula, and then we've got a clean slate for the next one. So go back up to y1. And we're just going to type in exactly as it looks, so 10 cos 20x. Sorry, not exactly as it looks, I'm going to put a bracket in as well. So 10 cos, I'm going to use a bracket just because I feel a lot more comfortable with that. 10 cos 20x, close the bracket, and then I'm just going to press draw. Now, so I can just about see a line down there, but it definitely doesn't. It isn't the answer, it isn't what you need it to be. And why should it be? Because we haven't done anything about the viewing window. So if we now go to, you can see V window up here, so I press Shift F3, and then it gets me to the V window. So you can see we've got these 4 values of interest. So X min, it's already on. I need to change that. And then I've got a max, which means X max, this is maximum X. Scale and dot, I'm not particularly bothered about. Y min and max I definitely are. So I've got Y min and max. So I need to make sure that these 4 values correspond to these. So X min needs to be the minimum value of X. It's right there in front of me, it's minus 15. So I need to change that value to minus 15. When you're putting a negative in, use the little mini minus there. So minus 15. X max is what it goes up to the other end, 15. You could also get it from here as well. So that needs to be 15. I'm going to skip over scale, I'm going to skip over dot, I'm going to go straight to ymin, and thankfully it's given us it. Now, sometimes if they're being very cruel, they might just give you the domain, as in the x values, and not the y's. In that case, you kind of have to do a bit of trial and error and just keep messing about with your window. But generally speaking, you're given all 4 values, so thankfully we have that. Ymin is also minus 15, so I'm going to type that in. And Ymax is 20. So once we've got those 4 values in, so minus 15, 15, minus 15, 20, we press execute twice, and then we just go to draw, so F6 for draw. And you can see this looks a lot more sensible. It looks like a cosine function that hopefully you remember studying. So I'm now ready to transfer it. I'm just going to get rid of these imaginary lines because they shouldn't really be there. Please don't draw a box around on your actual answer, just for me to make a point. Okay, so now I've got this line here. I need to transfer that onto the axis here. So you'll have it on a bit of paper, in the exam paper. So I've got really 1, 2, 3, 4, 5 points that I'm interested in, and then a basic shape needs to be right. So you can see you've got this wave, a cosine wave. You've got a maximum here that looks like it's on the y-axis, and it looks like it's about halfway up. So I'm just going to put a little dot there, so I know I need to go through there. I've got a minimum, local minimum here, and I've got another one here. They look pretty symmetrical, and they should be really. It's a cosine graph. And they look probably a little bit more than half the way along here, and maybe somewhere a bit more than half. I don't know. It's not that important that you get them bang on in the right place, but they certainly need to be in the right quadrant. So say I put this point over here, or if it's even on the axis, you're going to lose a mark there, but you probably get quite a lot of leeway sort of somewhere in this area here. And then those endpoints, I need to make sure they're the right side of the axis, I would say, for the mark. So if I tried to sort of finish the graph here, that's not going to look good. So I'm just looking at this. They're sort of a bit below the hump, aren't they? So a bit below. So my hump's up here. They're kind of maybe somewhere like that and like that. Another thing that I see people do a lot, don't extend beyond the domain that you've been given. So do make sure your line stops here. A lot of people just sort of carry it on. So now I need to just join with this nice wave like that. So up to here and down to the minimum and up to there. So that isn't bad actually. So it would definitely get 3 marks. I've got my 2 local minima here and here. I've got my maximum in the right place, and I've got these endpoints, and it doesn't go any further. It respects the domain. It looks good. So that's part A done. Part B, find the coordinates of the local maximum and minimum points. Well, I've been talking about them a lot. So I've got 2 minimums here, and I've got 1 maximum. So looking at the calculator, I need to find this point, and this point. Calculators are very, very good at finding minimums and maximums. They have a built-in function to do it. So for anything like that, I want this G-solve here. So I'm going to press Shift, G-solve, and I can see I go to min for minimum. Press min, and it's already, you can see it's gone straight to the first one. It says X is minus 9 and Y is minus 10. So this is the point minus 9, minus 10. I can just write in minus 9, 10. So there you go. I've got 1 mark already. It's just 3 marks. I'm literally just going to get 1 for each. So then, because they've got 2 minimums or minima, I can flip between these just by pressing the side arrows. I can just go straight to the other one, and that's telling me that's at 9, 10. So I've just moved across. This is the point 9, 10. I just write that down. And then I just need to find this maximum up here. So I'm going to go to G-solve again, Shift, G-solve, and I'm going to look for the maximum. And that is at the point, that is the point 0, 10. So 0, 10 is this one, 0, 10. Part C, on the same diagram, sketch the graph of y equals g of x, where g of x equals the absolute value of x plus 2 for x is greater than or equal to minus 15 and it's less than or equal to 15. So it's very handy. It's given us exactly the same domain, so that helps, especially when it wants us to sketch on the same diagram. So we're just going to go straight to the calculator and we're going to type this in. So you probably don't know what absolute value is on the calculator, so I will show you. I'm going to go to exit, and then it gets me back to the functions that I'm putting in. Now I'm going to keep the first line y1, and I'm going to have a y2. So I'm going to have two lines on the same calculator screen, which is perfect because I want to put two on the same diagram. I can use it for scale, as in to draw the line better, and also I'm going to need both lines for part D anyway if you look ahead. So the absolute value function can be found in option OPTN, and it's in numeric, so F5, and you can see it's the first one, ABS. If I press that, I get these absolute values. So these lines look exactly like that. So then I just type in x plus 2, and that's it. Execute and draw. And now you can see I've got two lines on there. I've got an absolute value function. Now hopefully you know enough about absolute value functions to know that if I'm taking the absolute value of the whole thing, it basically means you take the output value and they're never negative. So if it's negative, it goes positive. So if this is the line x plus 2, what happens is as soon as it gets to 0, you reflect the rest of the line so it's never negative. So it just takes the absolute sizes, not the sign. So you don't really need to know that for a calculator question. All I really need to do is get this sketched on. So that there's two straight line segments or sections, and it hits the x-axis. Now, if you want, you can find out where that point is, but you're only sketching. So I can see it's in between the y-axis and the this part of the cosine graph. So if I can sort of put it, I'm just going to put it down there so it's in between here and here. Then I've got two straight line sections. I'm just going to say, well, this one ends, well, it's a bit higher than the hump, so probably somewhere over here. That's the hump, maybe somewhere like that. And then the other one is probably a little bit higher. I don't think you'd lose a mark if you put it, if say you just went across, but looking at it is a bit higher. And you can see why it's a bit higher. It's got the same gradient but a different sign, and it's going from a bit further away. So I'm now just going to draw these two straight lines. So drawing and something like that. And that is my g of x for one more mark. G of x. Just going to label f of x, and this hopefully will help for the part D. Part D. Solve f of x equals g of x. So this is saying when are the x and y values shared of the two functions. So when does this function f of x equal g of x? So it happens when for the one given value of x or given values of x, they have exactly the same y values. So that happens here, and it happens here at the intersections between the two lines. So you can see at this point the x and y value is exactly identical on the red line, and the black line happens here as well. So there's going to be two answers. I need to find the intersections, and fortunately the calculator has a function that will do that for us. So it's in gsolve again, so shift gsolve, and I'm looking for intersect. And it's already gone straight to the first one. That says x equals minus 3.9405 and so on. Y equals 1.9405. Now, if it said write down the coordinates of the points of intersection, I would need the x values and the y values, a bit like where I was finding minimum and maximum point. In this case, it just said solve f of x equals g of x. So actually, I only need to know the x values, because you're effectively solving 10 cos 20x equals x plus 2 absolute value. So I'm just finding which x values make that true. So the answer only needs to involve x. So the first one is minus 3.94. Another thing, unless your answer is a very friendly answer, like a whole number or just a one decimal place, 0.5 or something like that, or if you say you've been told give this to two decimal places, give this to the nearest whole number, so on, Unless something like that happens, you should give these to 3 significant figures, and you will lose marks if you don't. If I'd just written minus 3.9, I would lose a mark for sure. Another thing, I've seen so many people lose marks for not writing the minus sign down, and I understand why, but it's quite hard to see. If you look here, that minus is really quite small, and it's very close to the equals, and it's just, if you're doing it quickly, I've seen it missed so many times, so just be careful. It's worth taking a bit of time on that, because I mean, if you're just careful on this, it's such an easy, how many marks? Such an easy 8-mark question. So I just now need the other point of intersection. Similar to the minimum points, you can navigate between them by using the side arrows, so I just press to the right. And this does give a nice answer. X equals 3, y equals 5. I just need the x value, so x equals 3. I'm actually going to just change this to x equals minus 3.943, or x equals 3, so 2 answers. If you just write down minus 3.943, I think you'd probably get the answer. You'd probably get the mark anyway. But it's better to be correct if possible. Okay, that's the end of the question. Now, hopefully you'll agree. It really is. If you can get your head around, get the window right, get your calculator in the right mode, and you've just practiced a bit, it's certainly a lot easier than most of the marks on the exam paper are going to be.